Good morning, students. Today we are going to discuss the last section of your first unit, real numbers, and that is the rational numbers and their decimal expansion. Now you all know that rational numbers are the numbers which can be expressed in the form of p upon q, where q is not equal to 0. And you also know that rational numbers have either a terminating decimal expansion or a non-terminating but repeating decimal expansion. So, when a rational number will have a terminating decimal expansion or when it will have a non-terminating repeating decimal expansion, regarding that we are going to discuss in this section. For that we have three important results or theorems. Let us start. First of all is theorem 1.5. So, it says let x be a rational number whose decimal expansion terminates. Means after some decimal points its expansion ends. Then such number can be expressed in the form p upon q, where p and q are co-primes. That is, they do not have any other factor except 1. And the prime factorization of q, that is the denominator, is of the form 2 raised to power n, 5 raised to power m, where n and m, that is exponents of 2 and 5, are non-negative integers. So what does it mean? That if there is a number whose decimal expansion terminates after some time, then such number can be expressed in the form of a rational number p upon q form, where your denominator is of the form 2 raised to power n, 5 raised to power m. Denominator should be of this form, and where n and m are non-negative integers. What does it mean? Non-negative integer means integers cannot be negative. It will be positive or it can be 0. So, let us understand this with the help of an example. For example, let us take a number 0.25. Now, this is a rational number whose decimal expansion terminates after 2 decimal points. So, if we have to change it in p upon q form or in the form of rational number, how we will do it? We can write it as 25 upon 100. Or further, we can write it as 100 as 10 raised to power 2. Now, if we do the prime factorization of both numerator and denominator, we will get 5 raised to power 2, and we can write 10 square as 2 raised to power 2 into 5 raised to power 2. Or if we cancel the common terms 5 square with 5 square, because this 5 square is dividing, so we will left with 1 upon 2 raised to power 2. So as per the theorem, this is a rational number which terminates after some time, after some points. So we can express this in the form of p upon q, where p and q both are co-primes. They do not have any common factor other than 1, and their prime factorization of q, this denominator, this prime factorization is of the form 2 raised to power n into 5 raised to power m. Here in this example, n is 2 and m is 0. Why m is 0? Because 5 raised to power 0 is equal to 1. As we do not have any factor 5, so we can write it like this: 5 raised to power 0 equals to 1. So m and n here are the non-negative integers. N is 2 and m is 0. In this way we can express any rational number.